All right, good. Okay, this is the last chapter. As you can see here, many of the information here we have already covered. What we need to talk about here is what are the things that you need to consider. What are the things that you need to consider? Can you read what's written there? I think you can, but for me, my screen is not coming. You need to consider when you are, imagine that you are building your strategy for your WAN. So you have to analyze two things. The need for distributed processing architecture to support business applications and communication requirements. And your company, you have different locations and you have distributed processing architecture. The second trend is WAN technologies and services available to meet to these needs. What is available and what can it do? So you need to consider these two things. All right. Right. What are the WAN alternatives? We can have dedicated WAN or dedicated channel like T1 or T3. T1 and T3 they are WAN connections. Uh, for many years, this was the original method. Okay, to get high traffic, high speed. The other method is frame relay. A frame relay is a switched network. The frame relay protocol can be used, okay, to over a dedicated line to provide a convenient multiplexing technique. We have studied frame relay, so we know about all the features of frame relay. The second alternative, so we have dedicated or we have public switched service, such as the dial-up modem. You know the modem dial-up. This is very cheap or inexpensive, but very low speed. Or in organization, we have the LAN and the PBX. They are equipped with the modem banks to provide low-cost supplemental data transmission service. And what they do, they will add up more than one modem together. We call them a modem pool or modem bank to increase the speed. But still, it's not efficient enough. And we have another thing about WAN. We can integrate network services. Yani I can integrate the telephony, the security, CCTV camera, the data in one network. We call this integrated network strategies. So your router should support also this integration. All right. Yes. We have this an old WAN technology. It was called X.25. It's legacy now. It stopped. Nobody is using it almost. So it determines the user network interface. Some of the features was that it's using call control packets for setting up and terminating virtual circuits, and they are carried over the same channel as data. And the multiplexing is done on layer 3. And both layer 2 and layer 3 do flow control and error control mechanism. That's why it was slow. It was doing this for accuracy. but it is causing overhead and inefficiency. So it's not suitable for high-speed digital communication nowadays. So this was replaced by frame relay. So it's designed to eliminate much of the overhead of X.25. The key features of frame relay, we have already studied that. Frame relay supports multiple connections over a single link. Call control signaling is carried on a separate logical connection from the user data. So also this increased the speed and efficiency. Multiplexing here is done at layer 2, not on layer 3. So it is faster, eliminating one entire layer. Yani you don't need to go up to layer 3. Just from layer 2, you are doing the multiplexing. And there is no hub by hub flow control and error control. These are the virtual circuits and frame relay virtual connections. We have studied about these. This is the on top is the packet switching. Okay, so each virtual circuit carries control and data. On the frame relay, we have multiple connections, independent connections. Okay, that's why frame relay is efficient. Okay, frame relay relies on virtual connections. But how do we handle congestion? Congestion control strategies are supported in frame relay by using congestion avoidance. So if I know that there is a congestion in that path, I will use another path. So procedures are used at the start of a congestion to minimize the effect on the network. And then we have congestion recovery procedure. It is used to prevent network collapse in the face of severe congestion. Okay, so we have these two congestion control and framework methods. And then we have this FECN and BECN. BECN meaning that backward explicit congestion notification. This means that if you have a PECN set to positive, meaning that indicates that the frame, the user, and the transmitter. Let me read it for you exactly. When you see this message, it means that indicates that the frame the user transmits on this logical connection may encounter congestion resource. Okay, and forward meaning that the the frame that have been received have faced congestion. That's the meaning. Indicates that the frame on this logical connection has encountered congested resources. Okay, so it's very powerful, and this is very important information for the network administrator. We have another technology called ATM. We talked about it before. It stands for Asynchronous Transfer Mode. It is similar in concept to frame relay, so it's using packet switching. It's also called cell relay, and it was developed because we needed higher speeds. It's much faster than X.25 and can support data rates several orders of magnitude greater than frame relay, of course, much faster than frame relay. We have virtual channels. Virtual channels, they are logical connections in ATM, and they are analogous to the virtual circuits in X.25 or frame relay data link. And it is the virtual channel is the basic unit of switching in ATM network. Then we have virtual paths. It is a bundle of virtual channels. We call them a path. Virtual, if you could, if we a group or bundle of virtual channels is called a virtual path. Okay. This chapter is for the FWA. Yeah, many of the information here is revision. Yes, you are right, but you need also to study it. Many of this information we have studied before. All right, so then we have ATM connection relationship, and some parts are first time yani explained in detail. This is an ATM connection, so we have a group of virtual channels consisting, which will constitute a virtual path. So what are the advantages of virtual paths? First of all, it's simplified network architecture, increased network performance and reliability. It will reduce the processing and short connection setup time, okay, and enhance network services. All right. Now we have another technology called MPLS. This is a new technology. It's been for now a few years, or many years now, but it's one of the latest technologies and very efficient. MPLS, multi-protocol label switching. So it's based on label switching. It's IP-based network services. It will speed up the packet forwarding process. It can also handle QoS very efficiently. Can carry many different types of traffic. And also MPLS can work with also ordinary IP routers. It will work also with ATM and frame relay. So it's very powerful, flexible. And it will can completely replace ATM. This is the MPLS operation. As you can see here, we have this label switching routers. So the routers, they are switching or forwarding the packets according to the label. Okay, so you are assigning a label, the router will, the label switching routers will forward it according to its label. That's why it's very fast. This is the MPLS label format. So we have the time to live. S is the bottom of the stack bit. TC is the traffic class. And then we have the label view. Okay. So this is the MPLS label format. Okay, another technology we talked about before is, but we were visiting again, just we have some more information here. The wide area Ethernet. Okay, so here we are using the Ethernet connectivity to do a WAN link. It is a high-speed alternative to traditional WAN service, but it is simpler and provides bandwidth. And why it's simpler? Because it's a flat network design based on layer 2 Ethernet. And it is basically, this is a VPN service for linking remote locations. Some people, they call it carrier Ethernet. Please know these names, or Ethernet 1. Okay. Some people also, they call it Metro Ethernet. Metro Ethernet. Metropolitan Area Network, MANS, or Metro Ethernet. They are all the same. Okay, this is a wide area Ethernet. We are not going to ask you in deep. This is just a high level view of the information. You need to know just very basic. If you are going to study networking, you need to learn more about this. So this is your wide area Ethernet core network. Okay, and then you have all these Ethernet switches and Ethernet LAN switches in the middle. We have also the cellular or mobile networks, okay, and they support users in locations that are very rural or very far, okay. As you can see here, we have a telephone. Telephone is using the public telecom communication switching network, your telephone network. Then you can connect it to a mobile telecommunication switching office so that it can communicate with mobile devices. We talked about the generations of satellite. We have first generation was analog, was very slow, did not support data, only for voice. Then we have second generation. Okay, it was using TDMA or CDMA. Then we had the third generation. There was data, but it was slow. Then we have the fourth generation or 4G. It's here they are saying it's currently being rolled out at the time of the book, but as you know now we have 4G and we have 5G even. These are the advantages of third generation. It was providing high-speed wireless communication in compared to second to G2. Okay, it was using TDMA or CDMA for the spectrum. 4G, we all know 4G. It is all based on IP. Can get data rate up to 100 megabits per second, and it dynamically share and use the network resources. And also it supports smooth handover. Yani when you are traveling, or let's say you are moving from one location to another, there is a smooth handover from circuit to circuit. And it supports high quality of service for next generation multimedia applications. So these are the comparisons. 3G, 4G. This is the frequency. Of course, 4G is using 8 giga. For the speed, download is 1 giga in 4G, and the upload is 500 megabits or half giga. The technology used in 3G is circuit switching and packet switching. In 4G, it's all packet switching and it's IP. This is the difference between third generation and fourth generation networks. Here, the third generation cellular network. As you can see here, you have the subscribers, and then we are using wire or fiber network. If you can see here in the 4G, we are using the WiMAX 2. So this is one of the most important differences. 4G is using WiMAX 2 or Wi-Fi. Okay, that's why it's more efficient. So you know this difference. 4G is using WiMAX or Wi-Fi. Okay, then we have the satellite communications to connect to the satellite. So you have one link is called uplink, yani sending to the satellite, and then when it is reflected from the satellite coming down, it's called downlink. The part of the satellite that is responsible for the communication is called transponder. Transponder. Okay. This is how it looks like. So you have your satellite communication. You have point-to-point link. I have point-to-point. And you see here, I have point-to-point. Or I have one is sending transmitter and how many people receiving. You see, that's why it's called broadcast link. Point-to-point or broadcast link. Okay. These are some applications or benefits of satellite network: television distribution, satellite radio services, long distance telephone transmission, private business data networks also. These are all benefits or applications of satellite network. Okay, now I'll take your questions.